we'll have some difficulty in sharing the screen. Become the presenter before sharing the content. So, is that something that you have to enable there, sir? For me to share the screen? Okay, I think now it's come up actually. Okay, as the screen comes up, the other question that was asked from the audience is like, what is learning rate and how does a learning rate actually is fixed? See, learning rate is normally is a static parameter that is originally being fixed. But 0 and 1, right? It will be maximum a value of 1 as far as the settings are concerned. And the learning rate will improvise based on the error value that you get from the model. This is for one of the participants who was asked. But more insights maybe at the end of the session we'll have some more questions with respect to learning rate, why learning rate is being provided. Okay. Right. So now the discussion is about convolution neural network. See why we have something like called as convolution neural network and why everybody is taking about this architecture. See, CNN is more of an architecture which is related to neural network, right? And any other architectures that you come across with my limited understanding, RNN, or that everything will always resemble CNN, but with little more unique features in their own way. Okay. I think you are able to see a Word document that I'm keeping in before you, right? Um, so if you're not able to see the details clearly, I'll project it properly. Okay. I think you're able to see my Word document text clearly.
Yes, sir. Clearly. It's clear.
Okay. Thank you. See, given some data, the first question which I learned, some couple of years back is like, if you want to compare two rows of data, the conventional mathematics, you say A minus B. A would be the first row value and the B would be the second row value. But the thing is like not all times whatever data that you have is numerical, then values can always be categorical values, right? So there what is a solution from the industry is you can go for one-not encoding. So the one-not encoding will allow you to convert a categorical data into a numerical data. So that's the first one that I've said. Okay, you can convert your data from categorical to numerical using a one-not encoding. And next is if you have a data where there's no class label at all, right? Like for example, if you look at a data set that you have created, wherein there is only columns in the data and there is no class label in the data, their only solution is you can actually go with the concept of using a k-means cluster. So what a k-means clustering will do is k-means clustering will allow you to give a class label for the given data. So the class label can be created based on your k-means clustering algorithm. There again, the question people will be asking is like, what is the type of data that you're looking? Are you looking at a real-time data or a non-real-time data? If you are looking at a real-time data, then what I would suggest is you can go for real-time k-means clustering is there. You can go for a real-time k-means clustering. If it's not a real-time data, that means it's a static data that you have downloaded or it's created earlier, then you can go for just a normal k-means clustering, right? One second. Right. Systems are faster, sometimes are not faster, but I don't know. Now, look at this data that you have. You have a data in front where there are some column values. Now, each of the columns here is called as feature, and what you are interested is you're finding it as a feature means you say that every row that you have is called as a feature vector. right? So all this together is one feature vector. If you have one more row of data, that becomes a second row feature vector, right? If you look at this, you can see here 6, 9, 11 features. So the size of the feature vector is 11, right? Okay. When you look at the dimension of the feature vector, it will be 11 minus 1. That means 10. Okay. And if you want to talk about dimensionality reduction, you use some concepts or you go for statistics, and if you are able to reduce the number of features less than 11, here it is 6, 9, 11, you can bring it to 8 or 9 using some technique that is called as dimensionality reduction, right? So now come to your CNN concept. What CNN generally says is, CNN says that I can take only data which is an image. So when you take an image is a square matrix, right, which is a set of rows and to convert your data into a square matrix. So the first requirement is you have to take your data as a 2D array, right? Then next comes the question of going for what is the size of data that you'll use. You would say that I'm going for training and I'm going for testing. So 70% you will go for training and 30% you will take the data for testing. And the next question would be like activation function. The common activation function that is generally used is ReLU. It's a standard activation function that is used in CNN. So here also I'm suggesting ReLU as an activation function, right? Then what we do is we go for layer level details. As I told you, hidden layers have different meanings here. So we have convolution layer, we have pooling layer is there. So one answer to everybody would be like, how are you actually taking care of overfitting of data? Or how are you taking care of regularization? Because we told no, when you go to the playground or TensorFlow, regularization has two types, L1, L2. How are you taking care of regularization and overfitting? Here we have something called as max pooling. Fine. Then next question would be like, okay, what are you doing every time to classify? You are trying to classify the data with the closest class label. Now, if you have a data with yourself and the data doesn't have a class label, okay, that's always a challenge every time. You will have a data which will not have a class label. Have a class label, you will have to go for a k-means clustering and you will have to give a class label for it. Here, people talk about something called a single class, two class, and multi-class. Single class as such is generally not taken, but two class is most common, right? So you say that either you have a fever or not, do not have a fever, right? Okay. The multi-class is most becoming common. Nowadays, if you ask how many types of fever is there, you will say it's a normal fever, viral fever. Somebody would say it's a COVID fever. It's an example of a multi-class, right? So you can give a class label for your data. So the class label can start with 0. So if there are 3 class labels, then you can say 0, 1, and 2, right? Now, next comes the question of how does a CNN work? Now, a CNN as such is discussed here under a supervised model. I'm again putting a note. I'm discussing CNN as a supervised model, not as an unsupervised model. So if it is a supervised model, what happens? I have to have a training data, and that training data need to have a class label, right? Okay. Training data is already classified by using k-means clustering. So there are certain number of classes that are available. So here we are looking at only binary class. That means class label as either 0 or it is said to be as 1, right? Now let's take for an example, we have 10 records, right? So 70% for training. So 7 records will be given for training and 3 records will be given for testing. Now let's see how does a CNN work, right? Okay, under the training phase. Under a training phase, what does a CNN does is CNN will actually convert the data into a square matrix. So as I told you, there are 7 columns, there are 7 rows. It is not a problem. If there are 7 columns and there are 6 rows, okay. So what it does is it converts it into a 7 cross 7 by padding with zeros. That means just filling it with zeros. It just convert it as a square matrix, right? Now, people will ask a general question, what is a parameter that you need to set? First one is going to be number of neurons, right? So number of neurons is actually corresponding to number of values, right? If you are feeding a data to the CNN, and let's take it's having 10 columns, 10 rows. Total number of values is 100 values. So the total number of neurons is naturally going to be 100. Okay. Now, the input data is represented in form of 100 neurons. Now the next step is it is given to the convolution layer. What is the convolution layer will actually do is a convolution layer will actually look for doing a convolution operation by doing a dot product with a weight matrix. Now, what is weight? Weight is again called as filter. Okay. Now, a general weight matrix will be at least of size 3 cross 3. Now, what you see is a weight matrix here. Okay. What you see is a weight matrix here. So, it is a filter, right? Now, when you look at a filter, the filters have different meaning. For example, if you go to the internet and search, you will find something called as mean filter is there, right? Median filters are there. So, you can take any filter of your choice. Now, what you see is a filter that is presented in front, right? Now, there's the input data. Now, what happens is this filter will be multiplied with the given data as a dot product operation, right? That means this first 3 cross 3 will be multiplied with the first 3 cross 3 here, right? And you will get a resultant value. And the same filter will get multiplied with the next 3 cross 3, right? The same filter will get multiplied with the next 3 cross 3. It goes repeated until it reaches the end of the data. Okay, this is what is called as convolution operation. So this is for one convolution layer. If you say the number of convolution layer is going to be 2, the result of applying this filter over this entire data will give you one data. On that data, you again apply a convolution operation with this filter. There, the number of convolution layers becomes 2, right? So convolution layer is user defined. You can give you a number of convolution layers as per your choice. After doing your convolution, it is given to the pooling layer. What is the purpose of pooling layer? Is purpose of pooling layer is to take every 2 cross 2 and take the maximal value out of it, and it will try to give the maximal value as a resultant. For example, after you do the convolution layer operation and the first 3 cross 3, right, in the given data is like this. What it does is it will take every 2 cross 2. For example, here if you can see, it will take the first 2 cross 2, that is 9100, 6991 it will take. Now it will try to take the maximal value out of it, right? And then it will provide the maximal value as a resultant. For example, 9100, what the maximum value is 100, right? 6991, the maximum value is 91. Then what it does is it goes to the next part. Okay, when it goes to the next part here, it will take the next 2 cross 2 and the final maximal value will be provided, right? This is what is done by with respect to the pooling layer. So what is achieved as a result of pooling layer is it will give a data which is lower in size. That means the dimension of the data will get reduced. If you can see here, the original data is 3 cross 3, it scales down to 2 cross 2, right? But the information retained remains the same. Okay, this is what happens under the pooling operation. After pooling, it is given to the fully connected layer. So what the fully connected layer will do is it will try to calculate the error. So the error formula is like this: a summation of I equal to 1 to n. N is your number of inputs, half of target minus output, the whole square, right? So output is an expected class, right? And target is the class that you got. Now somebody would ask among the discussion people saying that, okay, see, I didn't know the output at all. How do you say you got an output? The output class is predicted already by using a k-means cluster, right? If you give the original data to a k-means clustering, what will k-means clustering will do? It will associate a class value for every row of data. So there is an output that is already provided from a k-means clustering. You have got an output value which is a target by using your CNN. The difference of it will give you something called as your error component. If the error is high, it goes for one more epoch and keeps on going until the error becomes minimal. So what can be the minimal error? Can be an error with the highest amount of fraction. For example, a minimal error, let's take I got last time in the first epoch, right? My error value was 0.05. I'm running the model again. It became 0.05. So error value is minimal. I'm running it again. It became 0.0005. I'm running it again. It became again like 0.00005. So the lowest error that you are willing to accept from the model, where you feel that the accuracy has become very high, there you can stop your model. Okay, right? Now the same thing gets repeated for the testing part. When it comes to the testing phase, 30% of the data will be given, but it will not have any class label, right? Like from the training phase, what we got, we are able to get the weights that is being available, right? And as I told you, the weights will be updated every time during the epochs. That means the first epoch, the weight value is this. You can see here at first epoch, the weight value that is provided is this. But second time, the weight value will change based on the error value that it has got, right? So the testing part will actually try to go the same process like training, and it will try to compare what it is getting at the result, and then it will be able to say how much amount of accuracy is being calculated from CNN. Okay. This is how CNN works, convolution neural network works. But going from the other side, the theoretical discussions that we always take it up from CNN side, there are other concepts also that goes along with CNN which needs to be detailed. Okay, so we will discuss from there and then come back and take any questions that you want to take for CNN side first. One second. Give me a second. It takes some time to get to the full screen. So the summary is like this. CNN uses convolution layer and pooling layer, right? And weights will be updated at every epoch. The error will be calculated as the difference between the target and action. Right. See, usually there has been a common statement like why deep learning people will say that the features can be learned automatically from a given data. So what is features, right? Anything that is interesting from the data is called as a feature. For example, when you are taking a bill from a shop and the person has said, I've given you a discount. So the feature that you see added in your bill is discount. You go to some other shop, they give you only a bill, but there is no discount at all, right? So the new feature that has got created from the original data is discount in one shop, which is not existing in another shop. That's it. So features can be created. And why are we needing the features is to speak more about the data. What is that more about the data? You would say this shop is very good because it's giving me discount. The other shop is not giving me discount. It's not a good shop. Just I'm talking from my side. Okay. So the features are one that gets created from the given data. Please always understand. Now, if you take an image, somebody would say, what is a feature? A pixel is a feature. Now, what can be the next feature? Group of pixel connected together is a edge. So I have created edges. Edges is a feature. Somebody else will come from the other side and say, see, I have connected the edges. Now what I got is regions. So regions is a feature. So features can be created from the given data, right? So this is what we call as something called as feature engineering. But please always understand from my limited learning, what I have understood is you need to write code to create the features. Like I told you, if there is a price, okay, and quantity, price into quantity is the total price. Fine. But until you're given discount or something, you cannot create discount as a new feature from the given data. So you will have to write a code to generate features. But if you make a code for it, deep learning will create that feature for every data that you supply in the model. So this is what is called as feature engineering. Okay, right? So convolution layer, as I told you, will have a convolution layer, pooling layer, and fully connected layer. As you can see here, the CNN is taking input, it's got a convolution, and it's got pooling layer. So hidden layers are generally more connected with respect to convolution and pooling layer. And classification will happen under the fully connected layer that is in the output part, right? And most common function, as I told you, relu is the most common function which is used as an activate function in the case of CNN. Right now, I'm walking through an example again, a more detail with respect to CNN. At the end of it, you have any questions you can ask. Now, you see a complete data that is there. Now, this data that we are showing you is for an image. There's a weight matrix. This weight is nothing but the kernel, right? Weight is called as a filter. Okay. Now, what we do here is we have got a weight matrix which is initialized as 3 cross 3, right? Okay. Now, if you look at this here, now the next step what we are trying to do here is we are trying to show you a value which is called as 429, right? What is this 429 be? Is like the first 3 cross 3 multiplied by the weight, you will get again a 3 cross 3 matrix. Fine. Okay. Now, the sum of all the values that you get here after doing the multiplication, this 3 cross 3 multiplied by this 3 cross 3, you will get some values. Sum up all the values, right? You will get something called as 429. Okay. Now, the second step, what you are saying is I'm moving the same 3 cross 3 downward, right? Again, what you are doing here is you will get a new set of values. Sum up the values, you will get something called as 261, right? Now I'm taking this 3 cross 3, move it to the next 3 cross 3. I'm showing on the screen 54, 51, 239, 121, 75, 78, 24, 204, 113. I'm placing it here. You will get 3 by 3 matrix, which is new set of values. Sum up, you will get something called as 505. Okay. Now, finally, what is happening is when the original image that I have right now is a 6 cross 6. You can see here it's a square matrix. Multiplied by the weight, what I have is right now is 4 cross 4 matrix. Right? So the purpose of weight is to extract the features that we have from the original image. Right? If you don't have it as an image, you will say it is a data matrix. That's all. So the purpose of the weight is to extract the features from the original data, right? You can take it like that, and it will help you to do the prediction in the next process. Now the next operation is something called a stride, right? See, the filter or the weight matrix that we have here is moving across the original image, right? It's moving 1 pixels at a time. Like for example, it's 3 cross 3 is fixed on first 3 cross 3, then it moves next 3 cross 3, next 3 cross 3, right? Okay, so here the number of pixels it can move is something called as a stride. Okay, number of pixels it can move is something called as a stride. Now, for example, see here, stride equal to 1, right? So it's moving on the entire image. Operation completed, we get it. Now, when you say stride equal to 2, right? So what it is trying to say is it will try to move the weight matrix across the next set of pixels for the second level where the stride is 2, right? So n indicates a stride part. So n can be fixed based on your problem. So next is called as padding. As a keyword indicates, it means that we want to fill it with zeros, right? So let's take your image here. Originally we had it as 6 cross 6. Can you see here, right? So originally we had it as 6 cross 6. Now what we want to do is we want to convert it as a square matrix. Usually people will suggest that you can fill it with zeros randomly. But the common thing is, if it is an image, the information will be more in the corners. I think people will agree with me. Here there will be more information. Here there's more information. There is more information here. Here. So better you can do a zero process, that's your zero padding, across all the borders. So see here, in all the outer we are given you zeros, right? Okay. Now we can again do the same operation of multiplying the weight with the given data, convert it to a reduced matrix as you can see here, right? Right. See, that's the other way which people talk about why we go for something called as padding. Whenever we go for padding, what happens is the spatial size of the image is also getting reduced, right? Because since you are putting a zero padding in the outer, automatically the spatial size, no, on which you are trying to process will get reduced, right? And the other thing people always say is like the depth of the image when you are trying to work will not change whenever you're going for padding also. So next question people generally ask is like, what is the influence of this dimensions that we set? The dimension, first dimension is filters or depth, right? Filters as such, you can actually say the number of filters that you are trying to use. Some people will say I'm using more than one type of filter in my model, right? So usually the depth of the output will be dependent on the number of filters that you have used, right? So the other way around, people will say that the depth of the activation map is also equal to the depth of the filters. Now don't confuse about what is activation map. What is activation map is when you apply a filter, right, on the given image, right, or the given data. This is your filter. This is your weight matrix. I'm applying this weight matrix on the given data, right? I get a reduced matrix as you can see here. Matrix. This is called as your activation map. This is called as your activation map, right? So depth is more related to the activation map of your given data, right? So depth of the output will be equal to the number of filters. The depth of the activation map is again equal to the number of filters. The next is stride, right? Okay. Usually we move one pixel, right? As I told you, we will take first column, first is pixel, superimpose the original weight, and we can see the operation, right? But there is possibility that you can increase the number of pixels also. There you can actually go for increasing the stride value. So next is zero padding. Whether you're going for zero padding or not, it is actually a Boolean value. It will be either 1 or 0, right? Now what is the formula to calculate the output dimension is like this. W minus F plus 2P divided by S plus 1. So W is your input volume size. Okay. Let's take you take an RGB image. All of you will agree that if the image size is 32 cross 32, if it's a red, green, blue, we'll have red, green, blue, 3 matrices. So your input image size will be 32 by 32 by 3, right? Okay. And next, if you can go for F, F is nothing but the size of the filters. For example, let's assume that we are using 10 filters, right? So your number of filters that you are using here is 10, right? With respect to the input image 30 cross 32 cross 3, right? And next is the number of padding that you applied. So whether you're following your padding or not, it's a Boolean value. So here it will be 0 or 1. S will be your number of strides. Stride is generally set as 1, right? Now, if you apply on the formula, what is W here? W is 32, right? The next is F. F is nothing but the size of the filter. We are using 10 filters, but every filter size is 3 cross 3, right? So F will be 3. Next is P. P is nothing but the number of padding. So I'm using a padding for example. Let's take, right? So your padding value here is 0. S is nothing but the number of strides. So the stride value is 1. Okay. Now if you apply on the formula, what will happen here is this is 32, right? W is 32. F as such is 3, right? P anyway is 0, right? And when you talk about stride, S is 1 plus 1. So the output will be 3, 0, right? So given an input image of size 32 cross 32 cross 3 with 10 filters, with no zero padding and single stride, the output image size is reduced to 30 cross 30 cross 10. Okay, this is the formula to calculate the output dimensions when it comes to the case of CNN, right? Okay. Now, people generally ask about the output layer, right? As I told you, convolution layer and pooling layer is taking care of two things. One is a convolution layer is allowing you to extract the information. Extracting information here means features. A pooling layer is trying to reduce because every 2 cross 2 value is represented as one single value, right? So it is reducing the number of parameters from the original image, right? So now when you come to the case of an output layer, what an output layer will do is an output layer will have a loss function. Now I'm bringing you a keyword called as loss function. So an output layer will have a loss function, right? Example, it can be a categorical cross entropy loss function. to find out how much amount of error is there in prediction, right? So at every forward pass, right, automatically the weights will be learned, bias will be provided, right? And at every backward propagation, the weights will change, bias also will change in such a way that the loss is becoming minimum, right? So now you have two keywords in front of you, training error and next is testing error, and training loss and next is testing loss, right? So this is how SCNN model works, right, for all your information. Now, the next question people generally have is like going through the model generation, what happens like of CNN. One second. Yeah. I think people are able to see this folder. Are you able to see, please?
Yes, sir.
Participants?
Yes, sir.
Yeah,
Yes,
okay.
sir.
Fine. See, what a CNN model does, or any model does, is like it will generate you a model file. Okay, just understand it like this. It will create you a model file. So let's take you have a data. Now I'm showing you an example of how a T-leaf classification can be done by using a deep learning model architecture, right? Okay. Now the underlying code is written in Python. Okay. We will come down to that, but before that, let's come into the data. As I said, you will have training, testing, right? But when it comes to deep learning, what I told you, you'll have something called as validation data. So the validation data is like a trial data. Here you can go and keep on adding your data until you get a best model with a higher level of accuracy, right? Once you say, yes, I got a good model with a higher level of accuracy, your deep learning model is perfect to use. Just take it like that. Now let's come to the training data. Okay. When you come to your training data, you'll have both positive samples and also you'll have negative samples also. Here we are showing you positive samples under one category and negative samples under one category. So each sample is provided. You can see here, these are all negative samples. These are all positive samples, which is already provided in the other folder. Since it's a T-leaf classification, every T-leaf that you have is actually a positive sample. Which you say is not a T-leaf is a negative sample. Okay. So usually people say that the number of negative samples should be high. The reason is when the number is high, the amount of false positives is getting reduced. So please always understand, why are we going from one model to another model? Why are we going from one technique to another technique is to reduce. So you should always make a model analysis in such a way that the number of negative samples is high compared to the case of positive samples. Okay, now I've shown you the folder where there's positive and negative samples, right? Okay. Now the next part to be understood here is when you are trying to develop your model, first one that you are looking at is you are interested in actually predicting your data, right? You want to predict your data, saying that whether your data is classified properly or not. Okay. So here usually people get a question saying that what platform should I use, what technology should I use, all that. As I told you in the morning, please, from my understanding, I always suggest people to go for Python if it is image processing. Even if it is a data which is an Excel sheet or a notepad data to process also, Python is a good library right now. The reason is Python is more compatible for embedded environment, right? If you say I'm doing a face recognition system, then people will ask you tomorrow whether that face recognition system can come on a on-chip board. If it has to come on an on-chip board, then you are going to an IoT-based or an embedded application where your application is demanding saying that it should support Python. So there, Python is one good solution. So my suggestion to everybody is you can actually use Python. For most of the applications now, codes are there with Python. So Python with Keras, right, is standard. So along with Keras, either you can go for TensorFlow or you can go for Tian. Okay, 1 second. Okay, now the next question that you people ask always is like, okay, TensorFlow is fine. Okay, can I go for Windows or can I go for Linux? It's again up to you. You can either go for Windows or you can go for Linux. There is no difference at all. And most of the function libraries available in Windows are compatible when you go to Linux. Like, you will not find any difficulty here. Now, what I am trying to show you here is we are trying to have a T-leaf classification problem. So we have written a code which is based on the Python with Keras with TensorFlow. So it does a training process. At the end of training, what it does is it creates a model file like this. You can see here, right? So at the end of training, it creates a model file like this. Now this model file is given for testing with the second Python code, that is prediction. So this Python code will actually take this model file as input. It will run on the test data. The test data is this, which has got again positive samples. You can see here, which has got again positive and negative samples. As I told you, the negative samples will be more compared to the positive sample data. Then what it does is it does a prediction wherein it will say that the given data is now classified as the respective class, either it is 0 or 1. Right? So what we will try to do is we'll compare whether the test data is properly or not. Based on it, we will say the accuracy is improved in the given model. Expectation from this code. 1 second. Did the Excel sheet come up? Meanwhile, any questions from your side? Participants? Yes?
Hello.
Yes, please.
Hello, sir. I am audible to you.
Yeah, you are audible.
Yes, sir. Sir, very nice explanation you have given for CNN. I just have one doubt. So, while
Yes.
the filtering process, how to select the weight of the filter? You have taken the filter mask as 101. So, how to select that value? Or the
Ma'am,
accuracy of the classification depend upon that value?
okay. Thanks for asking this question. I think as such you can use what type of filter is dependent on your data. For example, if you have a data and you say that the noise is high, right? And preferably it is a frame from original video, you would say that you will go for a filter mask based on Gaussian. Ma'am, am I audible?
Yes, sir. You are audible. Yes, sir.
Yeah. So based on the nature of the data, you can decide your filter. If the data is actually a frame from a video, you can go for Gaussian filter, or you can go for standard medium filter is also fine. Hello.
Okay, sir. Yeah. Okay, sir. Yeah. Thank you, sir.
Yeah, thank you. Okay. See, after you run the test code, right, on the given data, here now it's a T example data. Each row here is actually corresponding to one data that we have from the testing image, right? So each row here to a data that we have from the test image. So as I told you, the error is given as half of the difference between the target minus actual, right? So we will try to get a error value like this. as we can see here, we will get a error value like this. This error value is again compared for our reference. For example, if you can look from here, the lowest error you are getting here is somewhere around 1 point something. You can see here. The lowest error is 1 point something. The highest error you are seeing in reference right now is 8 point something. Okay, right. So you will actually immediately say when it is 1 point something, the error is minimal. When it is 8 point something, the error is higher. So you can actually go back and say, okay, whether your classification is correct or not. Wherever you say that less than 3 point something, the classification is correct. Let's take it like this: less than 3.39, the classification is correct. If you take now, I will take this first. Oh, yeah. Let's take the first 10 rows of data, right? Let's take the first 10 rows of data. You are fixing a rule saying that less than 3.3, my error value is agreeable. That means my classification is correct, right? So that case, what you would say is, let's take this is correct. I'm putting it as y, okay, for understanding. This is not okay, okay, and this is correct. It is yes. This is correct. Yes. This is no. This is yes. This is no, this is no, this is yes, and this is no, right? So with my 10 samples which is given for testing, right? If I look at how much amount of accuracy I've achieved, it is 1, 2, 3, 4, 5. I'm counting number of yes alone because all that is correct, right? So my accuracy is given as 5 by 10. Accuracy is given as 5 by 10 because 5 samples have been correctly accurately classified and out of the total 10 samples. Fine. So this is how you actually calculate your accuracy when it comes to the case of deep learning. This what I'm showing you is the samples. Okay. Am I audible? Hello.
Yes, sir, you are audible.
Okay. Fine. Thank you. Now, when it comes to the case of writing a code, then the next question people will actually say is like, I would also like to write some code which is based on CNN, and I would like to run the code on the given data. Now, writing a code is not very difficult because there are a lot of code samples on the internet which is there. But usual suggestion which I say to the people is, please prefer your uh, programming environments to be matching, right? Make sure that it is built on Keras or Keras with Piano would be a good choice. Okay, one second. The environment is coming up. It's taking some time. Okay, so it will come up. Meanwhile, let's move on to the next one for discussion. Yeah. So next deep learning architecture we will take through is on RNN, Recurrent Neural Network. See, at this, I would like to talk about something about performance parameters in all these models. I think if people have been working, they would say, I work with data mining. People say I'm using precision, recall, accuracy. Same parameters you can use in machine learning also, right? Same parameters you can use with respect to deep learning also. But when you come to deep learning, you can actually use some additional parameters which are something called as error rate, which will be there in deep learning, and other one which you will which you will actually find other one which you will find with respect to deep learning is you will find something called as average precision, right? Average precision recall curve, right? So these are other things that you need to be very sure when you are writing papers or discussing your results when it comes to deep learning. When it comes to deep learning, please use average precision, precision recall curve, right? Would be other one. Our next important performance parameter is called as confusion matrix. Across all the learning techniques, whether it is data mining, machine learning, or deep learning, confusion matrix is the best one, which can say how much amount of misclassifications are happening in the data. And next is what I have learned from my research guides would be is like whenever you are looking at parameters, people make a practice of looking at all the parameters. Don't look at all the performance parameters. Depends on your problem, you should take your parameters. For example, if you want to say how many faces are there in the given image, precision recall is perfect, right? If you want to ask a question, how many faces are resembling exactly like your face, right? There what happens is you have to go for accuracy, need not go for precision and recall. So the discussion of parameters is also very important. Either you're going for precision recall or you're going for accuracy. Please do a proper understanding with respect to the data and do it, right? And last one is, in my last set of learnings, I've been trying to understand that precision recall curve, try to plot, also gives you more insight about the overfitting of the data and the outliers on the data. So please try making a precision recall curve also, right? And that's about the performance parameters. Now it's all become little simple because Python gives you libraries where you call the functions, automatically it gets calculated. But only thing is you will have to be very sure why are you using that particular parameter in the model, right? So the next architecture we are taking for discussion is recurrent neural networks, right, which is called as a RNN. See, RNN and other variants of RNN architectures are basically more related to state variation models. So what it actually says is, it says that you have a recurrent neuron and it will store the state of the previous input. It will combine with the current input also, but it will preserve some relationship between the current input and previous input. So it's more of a state-based models. You can take it like an understanding that it's more of a state-based models, right? So here, as such, what happens is here also we have an input layer, we have an output layer. So the input layer will receive the input, and the first hidden layer will have the activation functions being applied, and it will apply to the next hidden layer. It will keep on going. Finally, it will be able to get a final output. But each hidden layer will have its own set of weights and bias, right? This is one thing that you can try to make it a small difference between CNN and this one. CNN as such will say that the bias becomes uniform, right, at every hidden layer. But here it's not like that. Each hidden layer will have its own weights and also will have its own set of bias, right? And when you're looking at the state calculation, the formula is like this. The formula for calculating the current state is given as h suffix t, right? It will be given as f of the previous state. Previous state is what? H suffix t minus 1, right? Comma, the current input that you're provided, right? Okay. So next, if you are looking from an activation point of view, so h suffix t will be given as the activation function. So here we are looking at an activation function is tan h, right? Tan h of the product of the weights and the state, right? Okay. So you'll have wh into h suffix t minus 1 plus wth, sorry, whx into x suffix t. Now, what is this? Is whx is nothing but the weight at the current recurrent neuron, right? And w will be the weight at the input neuron, right? Okay. So every time the recurrent neuron will start taking the previous state from the original neuron that it has followed, right? Okay. Now, what is this purpose is like, you are trying to follow a sequencing model. Wherever you are trying to predict the new sequence, your new sequence is dependent on the old sequence. Like if you ask me what can be an appropriate example, wherever you're going for all this biocomputing, biosequencing models, they will say that we follow a sequence combination. Let's take you assume a sequence as H comma S comma T comma U. Just for a small example, H S T U. Now what can be the next sequence? Somebody would say H suffix X comma, then you would take a guess whether it is T. You say T, then you would say, okay, now you've got HXT. So automatically you might get U as a next sequence coming up. In such problems, these RNNs are very important to be applied, right? Okay. Once we calculate the current state is H suffix T with activation function that is tan H, right? We can actually calculate Y suffix T. What is Y suffix T? The expected final output, right? So Y suffix T is a final output. H suffix T is a new state, right? And W suffix HY would be the variant that you have got after applying your weight with the recurrent neurons, right? So right side what you see is a diagrammatic representation. Given an input X with an RNN, you are interested in finding what is the actual output. But since you say it's recurrent, you can see here it keeps on going for certain epochs, right? And finally it gives you an output. That's why. Now let's take a very more understanding for it. See, RNN again has got different categories, right? You have one-to-one RNN, right, which is a very traditional type of RNN network, right? You have one-to-one RNN is there, one-to-many RNN is there, then many-to-one is there, then you have many-to-many is there, and you have many-to-many, which is more, right? So let's see the differences here. All these differences are related to this two keywords. One is TX and next is TY. Okay, TX and TY. Now, one-to-one is X is 1, Y is 1. Right? Input is 1, output expected is also 1. Now, one to many, if you see here, given one input, but you might get expected to be many, right? Okay, so it is multiple output, but the input is only one, right? Okay, here the possible example people will say is music generation, right? You have only single musical note, but the way the person plays the musical note, you will find different sounds coming up as an output, right? That's an example of one to many, right? The next one is many to one RNN architecture. What is many to one? Many here stands for your input. One stands for your output, right? Okay. Here, the popular example that we say here is the sentiment that you express in the all the social media, right? Is an example. So you have only one output, but inputs are many. There are many words that you type, but finally you are giving only one output, right? You give a long writing about a movie review. Output is what? The review says whether it is good or bad about the movie. So there's many inputs, there's only one output, many to one. The fourth one is many to many RNN. Inputs are also many, outputs are also many, right? Okay. So here there are two variations that will generally come up. One variation is the inputs and outputs are totally the same, right? Okay. The second case is input is not equivalent to output. Let's take the first one. The input is equal to the output. So here, what is the meaning here? The number of input layers and the number of output layers are same, right? Here, our understanding here is like, given a set of named words, we are recognizing an entity, right? So here, the number of inputs with the outputs will resemble the same. Now, the next case is the number of inputs and the outputs will not be the same at all, right? They are of different size. Okay. Now, when you want to express something in particular language, right? Let's take for example, let's take somebody says, I love you, for example, right? As a three set of words in an English. They translate it to Spanish. It converts as Timo. It's only two words, right? But the meaning remains the same, right? Okay. So that is an example of a machine translation problem, which is to what we are talking about here. It's just many to many. Okay. So this in the diagram, what you are seeing many to many as two is of two categories. One is, as I told you, number of inputs is equal to number of outputs. And the next case is number of inputs is not equal to number of outputs. They are of different size. Now let's see how this model works with a small example, right? Let's take a small example where we have a text called as hello. the given input word is called as hello. As you can see here, we are trying to take the first four letters H, E, L, L, and we want to predict what is the next sequence letter that we will get. The next sequence letter we are expected to get is O, right? Okay. So the first vocabulary training says that we want to train the first four. First four is H, E, L, O, right? Okay. Now the inputs are one not encoded. You know what is one not encoding? Converting a categorical values into a numerical value. So now our vocabulary stands like this. H is one not encoded like this. E is one not encoded like this. L is one not encoded like this. And again the next L is encoded as like this. Okay, right. Now what we do is we are now converting this entire mapping as saying it's a neuron and we have got a weight, right? And this weight matrix is provided. Now, if you look at this here, we can actually see that we have initialized the weight matrix as a 3 cross 4. You can see here there is no uh, what to say, the mechanism about the weight matrix initialization that we have followed here. Since there are four letters here, H, E, L, L, for each of it we have encoded a weight matrix here. So it is 3 cross 4. Originally it's supposed to be 3 cross 3, but since we have four letters, it is 3 cross 4. Okay. Now let's see how an RNN works. Now the letter H is now provided here for the hidden state. So now what we want to calculate is we would need W into H into X suffix T. So the weight matrix is now provided, right? And next we are taking H, that's the first one here, and we are multiplying. After multiplying, right, and summing up along the rows, right? Row value, the equivalent value that we are getting here is this. Fine. Okay. Now, this is step 1. Now, the step 2 would be is like we are now moving on to the recurrent neuron, right? Wherein we have got a weight value that is provided. Now, if you can go back and see, the values that we got is 0.28, 0.90, 0.53. 0.28, 0.90, 0.53. After multiplying this with respect to H. Okay. Now the second step what we are doing is we are moving on to the recurrent neuron. So we are trying to take a weight matrix. Now let's assume it's a weight matrix of 1 cross 1 order. What we have right now is 0.42. The bias value that we got randomly initialized is 0.56, right? Now the question here is, now we already know H, which is a previous, right? And before H we don't have anything, right? So we need to calculate what would be the next state here. So let's calculate the next state part. So your weight value is 0.427043, right? Your bias is 0.56700. Here you'll have 1 also. I didn't put 1 here, right? You're multiplying with the previous one. What is previous? Before H you didn't get anything, right? Because the starting letter is H. So anyway, it's going to be 0, 0, 0, 0, right? Okay, this becomes your previous state. Just multiply with this. What we got is a first state value here, which is 0.5670001, right? This is your second step, right? Okay. Now, we want to calculate the current state. So the formula for current state, we have already said, we need to apply a tan function. If we can go back to the previous slide where we started our discussion, this is now done, right? With respect to H, we assume the previous state, nothing is before H is there, so it is all 0, 0, 0. Now we got a state that is available. Now we apply an activation function of tan H, right? With the current state that we have with respect to H, right? Okay, now the formula is applied. Now, since for H, there is no previous hidden state, we are applying a tan H function to the output and we get the current state, right? So what is your previous value that we got? 0.5670001, right? So here we take the original values that we have got from the weight matrix, 0.28, 0.90, 0.53. How did we get this 0.28, 0.90, 0.53 from here? 0.28, 0.90, 0.53, right? Okay. Plus the previous state values that we got. that is 0.56700. We sum it, we get the total value here, right? So total value is just sum of it, 0.567 plus 0.287, right? You will get 0.854028, right? Now, this as such, what we are trying to do here is we want to apply a tan function out of it. So tan h of this value, 0.854, 1.46, 1.10, we'll get a resultant value which is h suffix t, right? Which is this, right? Now, this is the state that we have currently from the, this is the state that we have currently from the original state value that we have, right? So now the values are 0.693, 0.899, 0.802. Now going forward, H is now completed, right? Now we are moving to the next letter. Next letter is what? E, right? Because originally it is HELLO. Now E is applied, right? So now we know the previous state with respect to H. What was the value that we got? The value that we got is 0.69, 0.89, 0.80, right? So just take that. You multiply it with the previous value, that is 0.427. Okay, so how did we get this 0.427 is here. You can see here the weight value that you have originally assumed is 0.427. So 0.427 into this values 0.69, 0.89, 0.80, right? Okay, plus the original weight values that we got. Original weight bias that we got is 0.56. Yeah. Original bias that we have fixed is 0.56700. Right? You add it, you will get your new values for the current state. What is the current state here? That is for E, right? Okay. Now you need to take this values, right? You need to take this values and keep it for reference, right? Now if you look at your WXH into XT, that is WHX is what we got originally, right? Multiplied by xt is what? The current state. That is for E. You will get your new set of values. Right. Now, we need to calculate again for E, h suffix t, right? That means tan h of the sum of the two values. What is the sum of the two values? One is 0.863, 0.95, 0.90, and the other one is 0.84, 0.87, 0.09, right? You will get your resultant value, apply your tan h function, right? Now again, you get your current state, right? Your recurrent neural network says what? You can actually produce the output right now with respect to E, because that is something previous to it, which is H, right? Now you take your WHY, multiply with respect to your HT. HT is this value, 0.936, 0.949, 0.762. You will get your new set of values, that is Y suffix T. Now the common statement would be is the probability for a particular letter from the vocabulary. Now we have taken H and E. Now it's generalized for the next letters also. The probability for a particular letter from the vocabulary can be calculated by applying a softmax function. So softmax function of the given set that we have with respect to H for all the letters in the given dictionary. This is how a state model generation is done with respect to RNN. That's a recurrent neural network. Small example, but when you go to your code and your libraries, the libraries are already coded with these principles. You have to give your data and it will automatically give you results. So, um, okay. So this was the expectation for the set. I have to take through on understanding on why we have something called as deep learning. What is the importance of data preparation? So as I told you, one principle that you can always follow is look at your data. If there's some categorical value, convert it as numerical value using one-hot encoding. If there's some noise, you go follow for some techniques for noise handling. Then next is choice of architectures. Whatever is the data, I would suggest people to go for CNN. Reason is when you go for proprietary architectures, you might not get the freedom of modifying the architecture. Okay, you will have to rely on how the code is written. So do one hand sketch code step by step with CNN. Then you go to any other technique. It can be transfer learning or any other model. Then choice of parameters, I would like to give an insight. That's why I told you precision recall versus accuracy. You choose. Not all models need precision recall and accuracy. But confusion matrix is a common principle. You have to go for confusion matrix. And since deep learning is a probabilistic approach, you can go for average precision also to justify why your model is perfect. Okay. Then last, which I was interested to clarify to people is like data as such is training data and testing data. But once you come to deep learning, you have something called as validation data. The validation data is like test data, but you keep on improving it until you get a stable model, right? And further insight, you can actually look at your application. What is your application that you want to work, whether it is a healthcare data or image processing data, or whether you look at emotional data. Based on that, you have convolutional models that has come up. For example, one of my team is working more on emotion models, so we are using something called as deep face net, right, which is an existing architecture that is there, and we are trying to improve that models, right? Scope of research, actually, my scholars, they work on video analytics. My PhD has been in around video processing. So I have been in video processing my research. Then I started doing with my scholars with video analytics. So we work more on emotion analysis, facial expression analysis, then activity recognition, right? Let's activity recognition means like given a video whether there's a fall of a person or not, like that. So there we work on architectures more related to deep learning side. There, what we are trying to learn right now is people are working on multimodal architectures. For example, combining k-means with CNN as a single architecture. Okay, or people are looking at stacked architectures. Stacked means have multiple deep learning architectures as one single architecture, and that's how the research is going on. That's it from my side. You have any questions, I'll be happy to answer. Participants, you have any questions, I'll be happy to answer. My session part is completed. Can you hear me?
Yes, we can hear you, Senthil sir.
Okay, sir. Fine, sir. Any questions from the audience?
Audience, if you have any queries, please ask.
Hello.
Yes, ma'am. Yes, please.
Hello, sir. I'm audible.
Yeah, I can hear.
Hello, hello, sir. Actually, I'm also doing the research in video analytics. Can you please suggest the standard data sets available for video which can be used for classification?
Okay, fine, ma'am. Okay. See, generally, with what I suggest is based on the application you work, you take your data. One is like Kaggle is one good source where you're getting a lot of video data set. Kaggle, and next
Kaggle.
is
Yeah.
yeah, Kaggle. Kaggle is one good data set repository, and next is if you can go to the internet and type outlier data set. Hello.
Yes, sir. Outlayer.
Yeah, outlier data set if you type, you will get the data set reference from Unibloom. Outlier data set, you will get the
Okay.
reference from Unibloom called as outlier detection data set.
Okay.
Outlier
Okay.
detection data set. It's a very good reference, right? Okay. Um, and third is Caltech, Calctech,
Calctech.
Tech, Caltech,
Okay.
Caltech, Caltech dataset.
Okay.
it's a good reference because the advantage is in 360-degree images of the data.
Okay.
Okay. I'm showing it on the screen also. When you type it, you get the outline data.
Okay,
Okay.
sir.
Then outlier IQ should have been the when you type outlier detection data set, you'll get a data set from Stony Brook.
Okay. Stony Brook.
Okay. Yeah. When you type outlier detection data set, you'll get a URL from Stony Brook. So that's a very good data set. Then actually my scholars, PhD scholars, they are working on one person is working on facial emotion data sets where we have
Okay.
created our own videos for facial emotion.
Okay.
I think you can see them on stonybrook.edu, right, on my screen. It's outlier detection data set. So we have created some data sets with respect to facial recognition, emotion analysis. Then we have one of my master student has got a data set created with respect to malpractice detection. So we have got videos that we have captured from where people data sets. Hello, hello.
Yes, yes, Senthil. Yeah, you are audible. There is no problem at all.
I have some
Yes,
students working on this emotion analysis, then classroom activity recognition. And this year, what we are working on is basically fall detection. Within a room, somebody stands, suddenly falls. It can be a health problem also. So we have made some online live data sets we have created for our reference. So if you work on a similar line like that, please write me a mail. I'll share the data set. Now you can reference it and use it.
Then please share your email ID.
Yeah, I'll share you my email ID. You can write me a mail. You,
there is another question from one of the participants in the chat box
yes,
asking, can you explain dropout, batch normalization, and regularization in CNN?
that's normalization. Hello.
Dropout, batch normalization, and regularizations.
Yeah, actually, batch normalization we generally go for when we want to go for batch-wise training. Like you see, when you have 1,000 records, you don't want to use all the 1,000 records. Instead, you want to use batches. Like I want to say, first 500 records I will train, right? Then I will use the next 500 records, right? There you can go for batch-wise training. There we'll go for batch-wise normalization, right? Dropout as such is a principle that is used within the CNN to understand the weights, right? How much amount of weight has to be trained at every place. So it's a dropout is a mechanism. You can set the dropout value. Okay, if you want to be very clear, a dropout is that you are using in your stacked architecture. That's your CNN architecture. Any other questions? Hello.
Yeah, I think there are no more questions. Yeah, one more question. Which platform do you suggest to implement these applications, MATLAB or Python?
Okay, I'm not against MATLAB, but as a research community, what I would say to people or students is you should look at something Keras with piano or TensorFlow. Okay,
Sir, please share the PPT of
this
CNN.
is also very popular. Okay, MATLAB, MATLAB is very good, but sometimes when we write research papers, the not much of open library compatibility is available with MATLAB. That is my experience. I don't know. I'm not very sure. And since most of the embedded applications in the lightweight code, no, will prefer to go for Python based Keras, and this combination of Theano, TensorFlow, or PyTorch will be good. And the programming environment framework, you can use Anaconda, right? And editor, you can use Spider or PyTorch, right? Editor, you can use Spider or not PyTorch, sorry, Jupyter. I hope this is clear. Hello.
Yes, sir. Yes, sir. Thank you so much, sir.
Yeah. Thank you. Actually,
Please do share the PPT of sir CNN, sir.
yeah, sure. I'll do it. And actually, my research part is more under video processing, video analytics, and I have a ongoing funded project going with IBM, where we work on network data. So we are trying to find deep learning models for detecting malwares in real-time network. So that's my ongoing research as a funded project.
Hi,
So
sir.
going forward, you can always write a mail. Maybe if our lines are similar, and if I can also learn in working with your problems, we will always try going together. And thanks to Chandramouli sir for taking my
Sir, actually,
on board.
sir, I'm also working on the same problem, malware detection on network data.
Sure, please write me a mail. What we are doing in malware detection is we are trying to look at honeypot network. So we have got a set of logs. On that, we are experimenting 7 deep learning architectures now. Okay, so we are trying to do a live analysis of detecting malwares. So that's what we are doing. It's got a good progress. This is a funded project that we got back in 2015. And then this is a second iteration also. We got this funded project. So it's a second level. So maybe you can write a mail. Maybe we will also learn something from your discussions. Okay, so thanks to Chandramouli sir for getting me for the discussion, and a pleasure talking to all of you. I think something should have been learned for all of you from my session, and my credits to my college. I studied from my bachelor's from BTech from Sedu Institute of Technology, Madurai, and my MTech from Pondicherry Engineering College, and my PhD from Anna University, Chennai. And thanks to my PhD guide, Dr. S. N. Shivanandam sir. He was formerly professor computer science in PhD Tech, and he's my guide. Who he only brought me into machine learning, and what I am today is because of my PhD guide. So thanks to my guide SNS sir for elevating me to what I am today. That's it from my side. Thank you all for your patient listening. If there's something more, please write me a mail. And Chandramouli sir, thank you again for your support and opportunity.
Yeah. I usually thank my guide also before ending my session. Now you done this, so people may think tomorrow if I do, I am copying you.
No, I've been doing the same. I know what I was earlier. Now I know what I am because of my guide session.
Exactly. Even
So,
the same quote I have written in my textbook on graphics.
oh, okay, very nice.
I was thankful to my guide there for molding me from a stone to what I am, better than a stone now.
Yeah. It's realities has to be accepted, right?
Yes.
So,
Yeah.
thank you all. So thank you so much, sir, for giving an opportunity to address your audience.
Yeah. Thank you. Yula, please.
Thank you, sir, for a very insightful and educative session on the fundamentals of data model and convolutional neural networks with the nice demos. And the way you taught each and everything was exemplary, sir. On behalf of all the participants, I'd like to extend my hearty thanks for your time and the knowledge you shared. It will be great pleasure for us to listen to you again in the future, sir. Thank you very much.
Thank you. Thank you all.
Ladies and gentlemen, I hope you all enjoyed this session. Let us break here now and come back after 1 hour 45 minutes for the next technical session. You may leave now and come back sharp by 3 p.m. I repeat, please come back sharp by 3 p.m. Thank you so much.
Thank you. Thank you all.
Thank you.